Hello, in this video I'll make you understand what Kadane's algorithm is. So Kadane's algorithm is an algorithm which is used to solve the question maximum sum subarray. So what is this? Let's say we have an array. We have 1, minus 2, 3, 4, 7, minus 7 and 5. Let's say we have an array like this. So what we have to do is we have to find a sub array, and that sub array's sum should be the maximum. Let's say we take this as a sub array. What is the sum of these two? This is minus 1. Let's say we take a sub array of this. So it is minus 2, 3 and 4. This is 7, minus 2, it is 5. So this is 5. So if you take this sub array, so this is 7. We have to find many sub arrays, and among those sub arrays we have to see which is giving the maximum sum. So if you use two for loops to find every sub array, and then after finding every sub array, if you try to take the sum of each and every sub array and then you compare and find the maximum of them, then it will give you a time complexity of O of n square. So this is a very high time complexity. So Kadane's algorithm will give us a time complexity of O of n. So now let's see how to use Kadane's algorithm. Let's say we have an array. So using Kadane's algorithm, what we are going to do is first we are going to traverse the array. So while we are traversing, we are going to add each element to a variable called current sum, and we'll also have an variable called max sum, which will be initially 0. So these both are 0. So while traversing, we are going to add the value inside current sum. So initially we will be here, we'll start the loop from here. So this 1 we will add over here, so it becomes 1. Now we move to the next location, we add minus 2 to 1, so it will become minus 1. So whenever you get a minus value, you should understand that if you move to the next element and add this 3 to the negative value, you can see that 3's value will become lesser. So this 3, if you add it over here, it will become 2. So you can see that the sum of these two elements is a negative value. Since it is a negative value, however large this value is, let's say this value is 1000. Even if it is as large as this number, this minus 1, when we add to this 1000, it is going to become lesser than its actual value. So what Kadane's algorithm says is, when you are traversing and you are adding each element to each other, whenever you find a negative value, it means you can discard it. So this entire sub array we are going to discard it, because this is having a total value which is negative, and because of this negative value, all the values which are coming next will become lesser than its actual value. As you can see here, it was minus 1. Because of this minus 1, this is going to become minus 999. So Kadane's algorithm says just discard it. So what you are going to do, whenever you are getting a negative value, you just stop over here, you make current sum as 0 again, and you are going to start fresh from the next value. So we are going to discard it, make it as 0 and start from this next value. So let's move to our previous example. So this element was 3 over here. So from here we are going to start. Now we are here. Now this 3 we are going to add it in current sum. Then we move to the next location. Okay, once we add 3 over here, we are going to store this 3 in max sum, because 3 is greater than 0. So max sum is now 3. Now we move to the next location. Now we add this 4 to this 3, it will become 7. Now you compare 7 and 3, Now 7 is the largest sum as compared to 3. So you make max sum as 7. Now you move to the next element. Now you see it is a minus 7. So you add minus 7 to current sum. So this will become 0. Now again you move to the next location. Now you have 5 over here. So if you add 5 to 0, it will become 5. Then you compare 5 and 7. 7 is greater than 5, so you would not modify max sum. So in this way you can see that while we are traversing, we are going to add each and every element. Whenever a subarray gives us a value which is negative, that negative value will only make other values smaller. So we are going to discard it and we are going to start fresh from the next element. This is Kadane's algorithm. Now let's quickly see one more example. So this is the same example. I have modified only this value. So let's apply Kadane's algorithm over here. We have current sum, we have max sum as 0. So we come over here, we add this value to current sum. We see that 1 is greater than 0, so we make it as max sum as 1. Now we move to the next location, we add this will make our current sum as negative value. Since it is making our current sum as negative, so we are going to discard it, make it as 0 and start again. So from here we are going to start. So this is 3, we are going to add 3. Now 3 is greater than 1, so we are going to make max sum as 3. Now we move to the next location, we add 4 to current sum, so this will become 7. Now 7 and 3, if we compare, 7 is larger, so max sum now is 7. Now we move to the next location. Now you see it is minus 8. Minus 8 plus 7, it will give us a value minus 1. So you see, when we get a negative value, we are going to discard it, make current sum as 0 once again, and we are going to start from the next location. So from here we are going to start again. So now we see 8 is there, we add 8 to 0. Now we compare 8 and 7, we see 8 is the larger value, so max sum is 8. So with just one traversal, we can find maximum sum subarray using Kadane's algorithm. So now let's write the code for this. Now let's declare the array. Now let's declare the variables current sum as 0 and max sum also as 0. Now we will use a loop to traverse. So we have int I equal to 0. From 0th index we are starting, and I less than a dot length. A dot length will give the length of the array, and then we have I plus plus. So using this for loop, we are going to traverse the array. So as I have explained, now we are over here, I is pointing over here, so we are going to add this value into current sum. So we'll say current sum equal to current sum plus the value present at ith index. So we are adding this to current sum. After adding, what we have to check? We have to check if this current sum is greater than max sum. If it is greater than max sum, we are going to update max sum with the new value. So we say if max sum is lesser than current sum, we will say max sum equal to current sum. I hope you get what I am doing. We are comparing current sum and max sum. Since we added 1 to the current sum is now 1. We are comparing 1 and max sum, and we are storing this 1 to max sum. Next, what we have to check? We have to check if current sum is not becoming a negative value. If it is becoming a negative value, what we have discussed is we will make current sum as 0 and we will start fresh. After the loop, we are going to print it. We are going to print the max sum. If you learned something from this video, please leave a like and consider subscribing to my channel. Thank you.